day 6, we are going to start looking at lines in motion. We're going to start talking about translating functions. So for the warm-up, what is the slope and the y-intercept of each of the following equations? So this goes back to Algebra 1. Also in geometry, we discussed how to graph a line in slope-intercept form. So if you recall, there was this equation that we used to represent slope-intercept form. So I'll write that right here, slope-intercept form, and I think you'll recognize it. It is this form y equals mx plus b. So if you recall, in slope-intercept form, the slope is the number next to the x. It doesn't include the x, but it is next to the x. So here we use the letter m for modulus of slope is where it came from. So here is m, and that is our slope. And then the y-intercept, so where the graph crosses at the y-axis, is the b value. So here is your y-intercept of a graph. So if we take a look at the following, it says, what is the slope and the y-intercept of each of the following equations? So again, slope is the number next to the x. So I'll write slope is 9. Your y-intercept, the starting value of the graph, is negative 13. Let's take a look at the next one. Again, the slope is the number next to the x, so if there's not a number next to the x, the invisible number is 1. So if you have the equation y equals 5 plus x, the slope would be 1. You would go up 1 over 1 in each direction. So slope is 1. The y-intercept is 5. So if you were to graph that, here's what it might look like. We would have our y-intercept of 5, and our graph would go up 1 over 1 in each direction. So this graph, y equals 5 plus x, would look something like that. Probably more straight though. All right, so today we have this new definition. A translation is when you slide an object without rotating, reflecting, or resizing it. So in geometry, you talked about translation, sliding an object without rotating, reflecting, or resizing it. In our investigation today, you will discover what happens to the equation of a linear function when you translate the graph of a line. So we're going to start with this parent function. So today, the parent function or the original function will be this, f of x equals 2x. So if you recall when we learned about functions, if we have y equals 2x, but it's a function, we can write it as f of x equals 2x, and that's in function notation. It just tells us that this equation is in fact a function. And so when we graph it, the y-intercept is 0, right? So we have it's plus 0, so the y-intercept is 0. And the slope is 2. So when you graph it, we're going to go up 2 to the right 1, up 2 to the right 1. I'm going to do that a few times. And then we'll draw our line. That looks something like that. That's not great. Let me do that again. Okay, so one more time. Okay, that's better. All right, so there's my graph, my function, f of x equals 2x. You can see why it's a function. It would pass the vertical line test. We could draw a vertical line anywhere on this graph, and it would meet the graph only once. Let's review domain and range first. Does it talk about that? No. So domain is all possible x values, and if you notice, the graph goes all the way right and all the way left. So here our domain is all real numbers, and so is our range, because our graph goes all the way up and all the way down. So there's a review of domain and range. It's all real numbers for both. All right, so how about this? Draw a line that's parallel to f of x equals 2x, but shifted down 4 units. What is the equation of this new line? All right, so it's the same. F of x equals 2x, but it's shifted down 4 units. So all I'm going to do is I'm going to take each point and move it down 4 units. All right, so again, we're just shifting this graph. And again, let's draw the equation of this, or the graph of this line. Okay, so it's my purple line. And if I look at the y-intercept, what's the y-intercept for this graph? And it's right here at negative 4. The slope is 2. I went up 2 over 1 in each direction. And so the equation of this graph is f of x minus 4. Let's try the next one. I'll change colors here. Draw the line that's parallel again to our original or parent function, f of x equals 2x, but it's shifted up 3 units. All right, so again, I'm going to start with the original function, the green, and go up 3 this time. So all I'm doing is taking every point and going up 3. And I'm going to draw that line. And let's get the equation of this blue line. The y-intercept, again, is where it crosses the y-axis, and that is at 3. So the equation for that graph is f of x equals the same slope, but then plus 3. All right, so hopefully now you're starting to notice a pattern with the graph and the equation. So for step 4, it says, if the equation of the function is f of x equals 2x minus 5, describe how you think the graph will be shifted from the original function. So we knew the graph of 2x minus 4 was down 4 units. So if you make a prediction, we would say that, let me switch colors here, the minus 5 would shift the graph. So graph shifts down because our y-intercept is moving down 5 units. Using Desmos, type in f of x equals 2x, hit enter, and type in f of x equals 2x minus 5. Was your prediction correct? All right, so I'm going to pull up Desmos. So desmos.com, let's graph, and let's type in our function. F of x equals 2x. There's our parent function. It's red right here. Let's type in, I'm going to go to projector mode. It's a little bit easier to see. Okay, let's type in f of x. I wonder if it'll let me do 2 f of x's equals 2x minus 5. Oh, yeah, let's me do 2 f of x's. And you can see, yep, that graph did shift down 5 units. Here's our new y-intercept at 0, negative 5. So yes, our prediction was correct. Put a yes here. Okay. So then it says make predictions about the following shifts of each of the functions below. Test your predictions in Desmos. So like the first one, I would see 2x plus 1, and I'm going to predict that that is going to go up 1 unit. So then again, to check my prediction, I'm just going to use my blue graph as my second graph, and I'm just going to change this to plus 1. And we can see that yes, every point did shift up 1 unit. So right now, you can pause the video and make a prediction, and then use Desmos to check these. And then when you unpause the video, I will put in the answers, and then we'll talk about the generalization. So again, if you pause the video, you can make your predictions. How will these graphs shift? And then test them using Desmos. All right, so hopefully you made these predictions and checked your answer. So if you notice, our parent function was the 2x every time. So if something was being added, that was the new y-intercept. So here it shifted up 1. Here it shifted up 3. Notice you can put the y-intercept first or second. The slope is always next to the x. And then if it was subtracted, it moved down. So minus 6 was down 6, and minus 1 was down 1. So in general, for this function, f of x equals 2x plus k. K is any number. If it's positive, it's going to go up k units. And if it's negative, it will go down. So this will be up k units. And k is some number. And then if it's negative k, it will go down that many units. Okay, step 8, it says, I should make this bigger, I apologize. Okay, so step 8, keep f of x equals 2x in Desmos and erase everything else. Describe what happens to the x-intercept and to the line when you type in the following. All right, so x-intercept is where it crosses the x-axis, so we'll be careful of that. So the x-intercept this time, not the y-intercept. All right, so let's try the first one. I'm going to type in 2 parentheses x minus 5. So here's the first one we're going to test, and we're going to see what happens to the x-intercept. Okay, so give me a minute. I'm going to pull up Desmos. I'll keep in the parent function. It'll be red. And this time in parentheses, so I'll put the 2 on the outside, but in the parentheses x minus 5. and I'm looking at the x-intercept. So the x-intercept was 0, and you can see that when it's minus 5, it goes 5 to the right. Okay, so let's write that down. So this moved right 5. Okay, make a prediction on if you change the 5 to a 7, what's going to happen. So I'm going to go ahead and type that in. I'll just change my 5 to a 7, and you'll see that our graph moves 7 to the right. So if we have the minus 7, it's right 7. What about if it's positive? Make a prediction. If you have parentheses and the plus 4 is positive, what happens? So let's say we don't want to make a prediction. Let's just type it in. And the plus 4 moves it 4 units to the left. Okay, so plus is to the left, kind of opposite of what you might think. Minus is to the right, plus is to the left. So this is left 4. All right, let's do 2 times x plus 7. Again, make a prediction. What do you think will happen? And I'll change my 4 to a 7. And if you predicted that it moved to the right 7, you would be correct. So this plus 7 is to the left, not right, left 7. So let's generalize this. So if you have parentheses, the only thing that's in the parentheses is the x and this h value. This is the left or right shift. So notice the 2 is on the outside. So again, the only thing in the parentheses is the x and the left or right shift. Minus h is actually to the right. So it's the opposite of what you think. So this is right h units. And if it's a plus, again, it's the opposite of what you think. This will be left 7 units. All right, so here's a summary of how your graph will shift horizontally, left and right, vertically, up and down, or both. So given any function, so we use 2x, but if it's any function, f of x, all right, if you have a number on the outside, so this k value, all right, plus k goes up k units, minus k goes down. Okay, so that k is what you think, up or down, and that's on the outside of the parentheses. But on the inside of the parentheses, if you have a minus h, this goes to the right, h units, and if you have a plus h, is to the left. So the h, the left and right shift, is opposite of what you think. All right, so let's do some examples, and then you'll be able to start your assignments on this page. All right, so example A, describe how this graph shifts from the parent function. So again, we have the same parent function, 2x. So we're just looking at the other numbers. So first is the 4 on the outside. This is up or down, and it's what you think. So this is up 4. And then on the inside is left or right, and it's opposite of what you think. So this will be to the right 3 units. Okay, let's try the next one. It says, the red graph is a translation of the function, the original zigzag function f of x. Write an equation for the red function, the shifted function. So for this one, you just got to figure out how many units everything moves. So I'm just going to pick a point. I'm just going to pick this point right here and see how it moves to the corresponding point in the red graph. It looks like it goes down 3, and it goes to the right 2. All right, so here's my original function, f of x. So we're going to y equals f. All right, so you keep everything the same in the original function. So if there was a 2, you would have kept the 2 on the outside. Here there's an f, keep the f there. But then if it's right 2, that goes inside the parentheses. So inside the parentheses is only the x and the left or right shift. So if it's to the right, that was minus. And then the up and down was on the outside, and it was what you think. So down 3 should be a minus 3. So the down 3 is the minus 3, and the right is the minus 2 on the inside of the parentheses. So your goal today is to be able to tell how a graph, how a function shifts up, down, left, or right, and then we'll review this more in tomorrow's lesson. So your daily practice starts here. And again, the answer key is posted so you can try it and check your answers. It just goes to page 32. So finish page 32, and it goes to page 33.